Math 76, Lesson 40, using 0 as a placeholder and circle graphs. So, using 0 as a placeholder is a technique that can be used on any decimal problems you may encounter. This can be addition, subtraction, or multiplication. And as we will later see when we divide division of decimal numbers sometimes. But 0 as a placeholder is just a method to help some people keep track of the spaces. So some of you might be losing your minds with all these weird empty spaces in your problems, or you might get confused when you run into a decimal problem and you don't have a space or a number in one of your place value spaces. Excuse me. So this method of using 0 as a placeholder is something that can help remedy that if you're having trouble with that, or if that's something that bothers you and it's hard to reconcile. So we have the subtraction problem, 3 minus 0.4. So this is a whole number minus a decimal. What we're going to do here is we're going to take our whole number, we're just going to turn it into a decimal and add what we call a placeholder 0. I think I alluded to this in a previous lesson, but the number 3 we will just rewrite as a decimal number by adding the decimal point, and then this 0 right here is called a placeholder 0. It doesn't actually give any value to the number. It doesn't change the value of the number 3, but it holds the place value of tenths, so that way we do not forget to use that place value. So then when we set this problem up as 3 and 0 tenths minus 4 tenths, we then have something that lines up perfectly, as opposed to something that might look like this, 3 minus 0 and 4 tenths. Right? So this doesn't look as aesthetically pleasing. Sometimes it's a little bothersome. So we have this placeholder 0. Exact same problem, exact same numbers. We'll get the exact same answers, but this one looks a little bit better, and it helps people work the problem a little bit better sometimes. So in order to solve, we'll go ahead and regroup this number 3 into a 2. We'll take one value over there, so that becomes 10 tenths as opposed to 0 tenths. 10 tenths minus 4 tenths gives me 6 tenths. I bring down my decimal point. 2 minus 0 is 2, and my final answer is 2 and 6 tenths. Here, it would be the same thing. You would just have to regroup this 3 into a 2, and then you'd have 10 tenths. 10 tenths minus 4 tenths gives us 6 tenths. Bring down the decimal point, and we get the same answer. So, same problem. One uses a placeholder, one doesn't. The placeholder might help a lot of you out. Now, let's go to the multiplication. This is where placeholders tend to be the most useful in making sure we get the correct answer. So every now and again, you'll get a multiplication problem where you'll add up your number of decimal places, and you'll see that the number of decimal places far exceeds the number of the numbers in your answer. So let's go ahead and demonstrate this. We have 12 hundredths times 3 tenths. Okay, 3 times 2 is 6. 3 times 1 is 3. And 3 times 0 is 0, and then all the other zeros are just going to be 0, so I don't actually have to multiply times any of these zeros. So let's say you're one of those people and you did it very quickly, and then you go to count your decimal places, right? So you've got your answer of 36, and then you go to count your decimal places. You see 1, 2, so you get 2 up here, and then 1, and then you get 1 up here, and you've got 3 decimal places for 2 numbers. Oh no, whatever will we do? Well, we're going to add a placeholder 0. So we take our space, we count 1, 2, 3, right? Notice I put the 3 around that blank space there. I'll put my decimal point, and then in that blank space, I'm going to add a placeholder 0 right there. And then I can also put another placeholder in front of the decimal point, letting everyone know, hey, look down here, there's a decimal point. So my final answer is going to be 0.036 thousandths. Or it can simply be read as 36 thousandths. Now let's talk about circle graphs. So to talk about circle graphs, I'm going to go to the book. All right, this right here we see. Well, camera's falling down on me again. Whoops. There we go. Oh, it also feels a little warm, like it's about to overheat. Maybe this should be my last video for the day. Okay. And then there's a shadow. Is that the shadow of the mic, or the shadow is the camera? That's what? Okay, I'm just being nitpicky. All right, we have here a circle graph. Now this graph is displaying information that Brett got from his classmates about pets they have at home. And we see the graph is broken, or sometimes it's also called a pie chart or a pie graph. We see we've got dogs, cats, birds, and fish. Those are the types of pets that people have at home. So the way we would read this is the entire circle would represent all of the pets, right? So all of the pets are represented by the entire circle. And then each section would be the exact number. So here we have 16 dogs, 8 cats, 4 birds, 4 fish. Pretty simple. And then we've got other different, we've got some questions about circle graph that your book will ask you. For example, they say, how many pets are represented in the graph? Well, we have 1, 2, 3, we have 4 sections. That's 4 different types of pets. That would be dogs, cats, birds, and fish. Wait, did they say types or how many pets? Ooh, they just wanted how many pets total. Okay, so they could say how many types of pets. That would be 4 types of pets, but I misread the question. They just want to know how many pets. So we've got 16 dogs, 8 cats, 4 birds, 4 fish. So we'd have to add all of these up together. 16 plus 4 is 20. 20 plus 4 is another 24. 24 plus 8 gives me 32. So if I add all 4 of these numbers up, I get the total number, which is 32 pets. There's 32 pets represented in the graph. Next, they want to know what fraction of the pets are birds. Okay, so if I want to know how many are birds, I take the number of birds, which is 4, and I would put it over the value of 32. So over here, I've got 32 pets total. Right? And then I've got 4 birds. So if I want to know the fraction of pets being birds, I would take the amount of 4 birds and I would put it over the total number of 32. Now, is that the proper fraction? No, because this can be reduced. Both 32 and 4 can be divided by 4. So when I divide them by 4, 4 divided by 4 is 1. 32 divided by 4 is 8. So 1/8 of the pets are birds. So 1/8 birds. And then now they ask, what percent of the pets are dogs? Ooh, okay. So now we look at our graph, and we can also use our percentage. If you still have your fraction manipulatives, you can use those as well. We can see clearly that this circle is cut in half. So if half the animals are dogs, then that means it's 50% are dogs. So you can use this doing your fraction manipulatives, or you can use it by looking at the shape and seeing the numbers. And then we can also double check this, right? So if we've got 16 dogs here, then there should be 16 pets on the other half. So if I have 4 fish and 4 birds, that's 8. And then 8 and 8 is 16. So that is half, or 50%. Okay, so that's how a circle graph works, or what some people would call a pie chart. And that's how you use it to answer questions. If you have any questions, let me know on the school website, and I will see you in class.